This is Ms. Humbert here, and today we're going to be doing Unit 8 Learning Target 14. So we're going to be talking about the distance formula and applying it to actual word problems. So let's take a look at this one. Okay, here's one thing that you need to know about the distance formula and the Pythagorean theorem. They actually are the same thing. So if it's a situation where you can set up a right triangle, you can feel free to use the Pythagorean theorem or the distance formula. It's up to you. For example, this is one where you could use both. A certain helicopter can fly 450 miles before it needs to refuel. Suppose a person needs to be flown from a hospital in Minneapolis to one in Chicago. So let's let this be Minneapolis up here, and let's have this be Chicago down here. So it's 225 miles east. So when we're talking about going east, and then we're going to go directly south, you'll notice that that forms a right angle, which means I have a right triangle, so I don't even need to worry about creating a distance formula because I can just use the Pythagorean theorem. So what I'm trying to do is, because an airplane isn't going to fly this way and then this way, or a helicopter, right? It's going to go along that hypotenuse. So what we need to do is figure out what our hypotenuse is. So what I'm going to do is I'm going to do 225 squared plus 175 squared. And that's going to be equal to x squared, which is the actual route that the helicopter is going to take. So I have 5,625 plus 30,625. And that's going to be equal to x squared. So when you add those together, what you end up getting is that x squared is equal to 81,250. So to solve for x, we need to take the square root. So I'm going to take the square root of both sides, and I end up getting 81,250 underneath the square root. Now, let's go ahead and simplify that radical. Well, I see that it ends in a 50, so I know that it's divisible by 50. So I could take out a 50, and I get 50 and 1,625. Now, 50 I can divide down to 25 and 2, and 25 breaks down to 5 and 5. Well, 1,625 is also going to be divisible by 25. And then it's going to be 25 and 65. Well, 65 only breaks down to 6 and 13. Or 5 and 13, I apologize. 5 and 13. So we have one pair of 5s, and then this 25 will break down to another pair of 5s. So I have one pair of 5s, two pair of 5s. So I have two pair of 5s that are going to come to the outside. So that's going to be 25 on the outside of my radical. And left underneath is 2 times 5 times 13, which is really just 65 times 2, which is 130. And there are no pairs of 130. So that's how many miles it can travel, but that doesn't necessarily answer our question. So what I'm going to do is get the actual decimal for that. So in my calculator, I'm going to type 25 times the square root of 130, and I end up getting 201.56 miles. Is that less than the 450 miles? Yeah, so it can go the whole way without refueling. Let's take a look at this golf ball problem. So Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. So let's draw out our cup here. So here's our cup, and we're going to call this the point 0, 0. So that's going to be like our origin. And so it says that she fell 20 feet short, so she's going to be 20 feet short. And remember, when you go down, it's negative. And 8 feet to the right, that's going to be positive. Now, when I write out the coordinate point of this, I want to have how far I'm going horizontally first. I'm going 8 horizontally, so that's going to go first. And then I'm going 20 down, so that's going to be second. On her first putt, the ball lands 2 feet to the left. Now, whenever you go to the left, it's going to be negative. So I'm going to write that as a -2. And then it's going to go 3 feet beyond the cup. So now I want to write out the coordinate point for that one. So I'm going to do my horizontal distance first, which is -2, and then my vertical distance, which is 3. So I have -2, 3 at 8, -20. That's what I'm trying to calculate out the distance between. Are those 2 points? Are -8, 20, or sorry, 8, -20, and -2, 3. We're trying to calculate out the distance between those 2 points. Okay, so let's start out. We're going to do x2 minus x1. Again, that 8 should be positive. I made a boo-boo there. So it's going to be negative when you subtract it. So that's going to be -2 minus 8, quantity squared, plus 3 minus a -20. Now remember, when you subtract a negative, that's going to become plus a positive. And then we're going to square that. So then we're going to end up getting the square root of negative 10 squared plus 23 squared when you add those together. So let's go ahead and let's square those. So then what you end up getting is the square root of 100, because that's 10 squared, and 23 squared, which is 529. Then you end up getting the square root of 629 squared. Go ahead and pause the video. See if you can simplify that down at all. And I'm actually going to save you guys some time because you can't. There are no pairs, but you need to check at the end every time you do a distance formula. Since there's no pairs, that's our final answer. Let's take a look at number 3. On her college campus, Kelly has her first class in Rhodes Hall and her second class in Fulton Lab. So what I'm going to do is I am going to call this right here, Rhodes Hall, is going to be the point 0, 0. So then let's take a look at how far I'm traveling. Well, first of all, these are all in eighths, and this is in a fourth. So in order for us to add the fraction, they all have to be the same. So I'm just going to make a note that 1/4 is going to be the same fraction as 2/8. Okay, so it looks like we're going right 2/8 and then right 1/8. So that means we're going a total distance of 3/8 over here to the right, so it's going to be positive. And then we're going down 3/8 here, so that's going to be a negative 3/8. So now we're going to use the point 0, 0 and the point 3/8 to calculate out the distance. So what I'm going to have is 0 minus 3/8 quantity squared plus 0 minus a negative is going to be plus 3/8 quantity squared. So now when we square these fractions, what we want to do is we want to square the top and we want to square the bottom. So 3 squared is 9, 8 squared is 64, plus 3 squared is 9, divided by 8 squared is 64. So these are two fractions that we can add together. And what we end up getting is the square root of 9 plus 9, which is 18. Now remember, when you add fractions, when you add them, you keep that denominator the same. So that's going to be 64. So now let's break these up into two fractions. Well, I know the square root of 64 is a whole number, so I don't even have to rationalize the denominator. That's just going to be 8. But what I do need to do is break down the square root of 18. Well, 18, I can do 9 and 2, and then I can do 3 and 3. So I can take out a pair of 3's, and then left underneath the radical is 2. Well, that fraction cannot be simplified anymore. So if I were to walk diagonally, I would be walking 3 square root of 2 divided by 8 miles. Let's take a look at number 4. The isosceles triangle has two sides of equal length. So we want to figure out if AB, that length, is the same as BC, is the same as AC. So let's go ahead and let's calculate out the distance between A and B. So to calculate out the distance between A and B, we're going to use those 2 points there. So I'm going to do x2 minus x1 minus a negative is going to be plus a positive. And then I'm going to do y2, which is 2, minus y1. And then square it. Okay, so then what I end up getting underneath the radical then is going to be the square root of 8 squared plus a negative 2 squared, which is the square root of, come on, stupid computer, go faster, the square root of 16 plus 4, which is the square root of 20. And when you get the square root of 20, you can actually break that down. So you can break this down into 4 and 5, and then 2 and 2. So when you take out a pair of 2's, you end up getting 2 square root of 5. So that's for AB. So after we calculate out AB, then we want to calculate out BC. So BC has the point 5, 2, and negative 1, negative 5. So let's go ahead and let's calc that out. So then let's take a look at BC. So we're going to do y2 or x2 minus x1 and square it plus y2 minus y1 and square it. So then what you end up getting is you end up getting the square root of negative 6 squared plus negative 7 squared, which is the square root of, oh my goodness, this is so frustrating that the internet's so slow. the square root of 36 plus 49. So then you get the square root of 85. So far we still do not have what we need. So now we need to check AC. So when we do AC, we're going to have AC is equal to the square root, so then we're going to do x2 minus x1, that's going to become plus a positive when you subtract off a negative, plus y2 minus y1, and then square it. So then what we end up getting is the square root of 2 squared plus 9 squared. So that's going to be equal to the square root of 4 plus 81, which is equal to the square root of 85. So since both of those end up being the square root of 85, then yes, we do have an isosceles triangle because we have two sides that are the same length. All right, so let's go ahead and let's take a look at this next problem here. So we're going to do another mini golf problem. So what we're going to do is we're going to set up our golf again at 0, 0. So this hole right here is going to represent the point 0, 0. And then what we are going to do is she's going to hit her ball 12 feet past the hole, so this is going to be 12, and 3 feet to the left. Now remember, going to the left is negative. So we have the point negative 3, 12. Then we're going to go 2 feet beyond the hole, which is going to be a negative 2 when you're going down, and 1 foot to the right. So we always go how many we're going horizontally first, and then how many we're going up and down. So now we want to calculate out the distance between that point right there. So let's go ahead and let's calculate out the distance. So we're going to do x2 minus x1. So minus a negative 3 is going to become plus a positive. And then y2, which is negative 2, minus y1, which is 12, and then square it. So then what we end up getting is we end up getting the square root of 4 squared plus the plus negative 24 squared. Or negative 14, not negative 24. Good one, Miss Humbert. It's supposed to be a 1. Okay, so then what we end up getting is 4 squared is 16. So we get the square root of 16 plus 24 squared, or 14 squared, sorry, I keep doing that, which is 196. So then you end up getting the square root of 212. So what I did is I divided 212 divided by 4, and that split up into 4 and 53. 53 is a prime number, but you can break 4 down into 2 and 2. So there's a pair of 2's that we can take out. So we get 2 times the square root of 53, and then our label is going to be feet for that one. Alrighty, so let's go ahead now and let's take a look at number 6. So Mr. Berg, Mr. Cush, and Mr. Miller are getting ready for their Pep Fest. So Mr. Berg we're going to put at the origin right here. So there's Mr. Berg right there. Okay, then it says that Mr. Cush is standing 7 feet to the right. Well, 7 feet to the right is going to be about right here, and then 3 feet in front of. So that's going to be about right here. Since we went right and up, it's both positive. So we went 7 feet up, or over, and 3 feet up. Then for Mr. Miller, he's 6 feet to the left. So notice that's going to be negative 6, and then 8 feet in front. So there's Mr. Miller. So that's going to be negative 6, negative 8 for Mr. Miller because he's standing on that other side of the coordinate plane. So let's go ahead and let's do the distance formula. So we're going to have x2 minus x1. When you subtract off 6, it's going to become positive. It only becomes positive if you're subtracting a negative. And then y2 minus y1, which is 8, so that's going to be positive since it was a negative 8. So then I'm going to end up getting the square root of 13 squared plus, oh, I'm sorry, this 8 should be positive because you went up. Oh my goodness. So that's a minus. I apologize. So that's going to be a negative 5 squared. So then you end up getting 13 squared, which is 169, plus a negative 5 squared, which is 25. So 169 plus 25 is going to give us the square root of 194. So I went through 194 and I divided it by 2, and then I got 97, and I just couldn't find any pairs. So 194 is actually as simplified as it gets. So that's your final answer for number 6. Next, let's take a look at number 7. So for number 7, it says that Mrs. Johnson decided to walk to school today. How far is she from her home after walking 4 miles east and 6 miles south? Now remember when we're talking about directions and you switch directly from east to south, you're forming a right angle. So 4, 6. So this is one that, again, I can use the Pythagorean theorem on to get that distance. So I have 4 squared plus 6 squared is equal to x squared. Okay? So then 4 squared is 16, plus 6 squared is 36, and that's going to be equal to x squared. So now what we want to do is we want to take 16 and 36 and add them together, and that's going to give us 52. So x squared is equal to 52. So in order to get what x is equal to, we're going to have to take the square root of both sides. So then x is equal to the square root of 52. So we need to try and simplify out 52. Well, 52 is divisible by 4, so I get 4 and 13. And then 4 is going to be broken down into 2 and 2. So from 4, I can take out a pair of 2's. So I take out a pair of 2's, and left over is 13. Now, in the original problem, it was miles. So Mrs. Johnson is traveling 2 square root of 13 miles to get to school. All right, let's take a look at number 8. Now, Mr. Peshman's going to be doing basically the same thing, but he's walking to the store. And he went 3 miles west and then 6 miles north. Remember, we switched directly from west to north. So again, we have that right angle. And the diagonal that he traveled is going to be our hypotenuse. So I can do 3 squared plus 6 squared is equal to x squared. Well, 3 squared is 9, 6 squared is 36, and that's equal to x squared. So now I need to go ahead and I need to add those two together. So 9 plus 36 is going to give me 45. So I get that x squared is equal to 45. Now I need to solve that for x, so I can go ahead and take the square root of both sides. And then I get that x is equal to the square root of 45. So then, when I get the square root of 45, I can break that down into 9 and 5, and the 9 I can break down to 3 and 3. So I can go ahead and take out a pair of 3's, and then left underneath the radical is going to be that 5. And again, our label is miles. So that concludes your note video for today. Go ahead and show me your completed note sheet once you are done. Thanks for listening.